Now, sometimes there's a theory called the fundamental counting principle. And I think it's better just to think of things in terms of a tree diagram, but I'm going to describe it anyway in case you come across of it. So the idea is that you think of each stage in a tree diagram, well, as a stage. So when we had, for example, let me find one of my tree diagrams. All right, so this was a stage, and that was a stage, and this was a stage, and this was a stage. And for each stage, you had to make a choice, and you were going to choose one thing in those stages. So if you had P options in the first stage, and Q options in the second stage, and R options in the third stage, and so on and so forth, S options in the fourth stage, T, whatever, then the total number of ways you're going to have is kind of what we said. It's going to be P times Q times R, and dot 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 in math is code for etc., etc. Okay, let's change gears. This is example number 4 that I've pre-written because I wanted to draw this picture and I thought it would take me time to draw it since it's very high quality. So you can pause the video and write it down. So what we have is we have a bag that contains 6 marbles, and the marbles are a solid red, I think that was my red, well, whatever. Solid red, solid pink, solid green, solid cyan, a striped magenta, and a striped turquoise. And we're going to do something with this bag. It's going to be a part A, part B, and so on and so forth. So for all of these, what we're going to do is we're going to draw 2 marbles, one after the other. Right, so I might draw this solid one, and then I would hold it in my left hand, and then reach in and grab the next one, and the next one maybe turns out to be this, my striped magenta, and then these are the 2 marbles that I've drawn. So I'm going to draw two of the 6 marbles, one and then the other. So that's what I'm doing. Now, I'm doing that for every part. So part A is how many different ways to pick out the marbles. And for the purposes of this question, we're going to assume that order matters. So if you have this followed by this, that's going to be different than this followed by this. So these would not be the same. So order is going to matter. So how many ways to pick out all the marbles? So I would pause the video, try to figure it out yourself. Presumably you have an answer. So what we have is, first we have, I'll do it as a tree diagram. For the first marble we pick out, we have 6 options. One, right? We could pick out any of the 6 marbles. Right? So we could pick out the red, the pink, the green, the cyan, what else did I have? Magenta and turquoise. Now if I pick out the red, so there were 6 options here. Now for the second one, once I've picked out the red, I can't pick out the red anymore. So there's going to be now only 5 options because the red one's gone. So now there would only be pink, green, cyan, magenta, and turquoise. And for each of these, there's only going to be 5 left because we've always taken one out. So there's 6 options for the first, and then for each of those 6, there's 5 options for the second, which means overall we're going to have 30 different ways to pick out the marbles. Okay. B. How many different ways to pick the 2 marbles? And we're going to assume that such that neither is striped. Now we're going to have to start interpreting language. So in this particular question, so again, I would say pause the video, see if you can figure out yourself. Now we're picking it back up. Neither is striped could be worded in a different way. So another way of wording neither is striped, we could have said such that both are solid. So if neither, in order for neither to be striped, both of them have to be solid. And these two mean the exact same thing. I was going to draw a tree diagram. It starts with a dot. And so both of them have to be solid. So my first option, I'm going to have red, pink, green, or cyan. Oop, and cyan's a bit off the screen. So red, pink, green, or cyan. And then for the second one, well, now that red's gone, there was 4 options. Now there's only going to be 3 options, because now we have pink, green, or cyan. 3 options, 3 options, 3 options. Overall, there was 4 options for each of the first, 3 options for each of the second. We're going to have a total of 12 ways of doing this. So we have a total of 12 ways of doing it. There's 4 times 3, 12. Okay. C. How many ways such that both are straight? Well, that's a bit easier. Again, you can pause it if you want, but so the only 2 striped ones are, the first one had better be magenta and the second one, or turquoise. If we pick the magenta, it's got to be turquoise next. If we pick the turquoise, it's got to be the magenta next. So this bag example is one where, so unlike the clothing one or the cupcakes, every time we take one out, we have one less available kind of in our pool. It's a different type of example. It's not quite the same as the other one. So often when you have these problems, you're going to have to keep track of, is this one where we're removing things, or is this one where we're not removing things from the pool? In this case, there's 2 options, or 1 option. If we multiply them, there's a total of 2 ways to do it. And they both look kind of similar. Okay. D. How many ways such that at least one of the 2 balls is solid? What we're going to learn is that if you see at least, that's generally code for this is a tricky question. At least or at most are very dangerous words in this course. So there's a couple ways of doing this. So I'm going to show you how to do this in 2 different ways. So pause the video, try and do it yourself. And now, assuming you've tried it, so the first thing we're going to do is something that I'm going to call direct. So direct is going to be, we're just going to count it. So what we have is we have we could take anything for the first one. So we could have red, what was it again? Red, pink, green, cyan, magenta, or turquoise. If it's red, then at least one of the balls is solid, so we could take any of the others for 5. So 1, 2, 3, 4, 5. So we have a total of 5 options, right? And if it's pink, we also have 5 options, and if it's green, we have 5 options, and if it's cyan, we have 5 options. If it's magenta, though, the next one has to be solid, because at least one of the 2 balls has to be solid. So that one's going to be a bit different. If it's magenta, it must be one of the 4 solid ones. So for these, it must be one of these. For those, it must be that. We add them all up. We get 28 different ways. And that's a direct way of doing it. And that's a fine way of doing it. I'm going to show you a different way, though. So we're still doing part D. We're still doing D. So we want to have at least one solid. So at least one solid. And what we're going to do is we're going to do something called indirect. And the way indirect works is I'm going to say, so first of all, how many ways to get, the number of ways to get 2 marbles. We already calculated that. If there's, that was A. So the number of ways to get 2 marbles is 30. There's 30 ways to get 2 marbles. Now I want to say how many ways to get both striped. So the number of ways to get both striped, that was this one over here, and there's only 2 ways to get both striped. Now if they're not both striped, then what that means is that at least one of them has to be solid. So if they're not both striped, at least one of them has to be solid. So what that tells us is the number of ways to get at least one solid is going to be the total number of ways minus all the ways that don't work. So I'll call those the bad ways. They're not morally bad, just they don't happen to work for this. So it's going to be 30 minus 2, which is 28. So the total minus bad equals the good is, and that's what we're going to call the indirect way of calculating things. And that gave us the same answer. So we have 2 ways, direct, indirect, both give us the same answer.